Memorizing something is actually very simple. The problem is that as time goes by, this tends to be forgotten. On the other hand, when we want to understand something, we need to invest more time. Fortunately, if you understand something well, it's very hard for you to forget it. In this video, I don't just intend to ask you to memorize a formula and then do some exercises that look similar. What I actually intend is for you to see where the formulas come from, so that you can understand them and solve any exercise related to the topic. So in this video, I'm really going to show you how we can calculate the sum of the exterior angles in convex polygons. Let's get started. I'll start with this equilateral triangle. You'll agree with me that each of its interior angles measures 60 degrees, right? Since 60 times 3 gives me 180 degrees, which is what the sum of the interior angles in any triangle should be. We're good so far, right? Perfect. Now, let me draw some exterior angles here. To do this, we're simply going to extend each of the lines. So we extend over here, and we're also going to extend this other line. This one I have marked here is an exterior angle. This is another exterior angle, and this is another exterior angle. We want to know what the sum of these three exterior angles has to be. So it's very simple. We're just going to calculate them and then add them up, right? And we'll find out what we get. So come on, let's go. Let's see. We already know that from here to here is a straight angle, right? Therefore, it means that since this one measures 60 degrees, then this angle must measure 120 degrees. Since 120 degrees plus 60 degrees gives me 180 degrees. That is, I get the straight angle, right? Now, let's do the same thing here. Look, between this one and this one, they have to add up to 180 degrees. Therefore, this angle also has to measure 120 degrees. And here, the same thing. This angle also has to measure 120 degrees. So now we just have to add 120 plus 120 plus 120. We do the addition. I get 0, 6, and 3. That gives me a total of 360 degrees. With this, I can now conclude that the sum of the three exterior angles of a triangle is 360 degrees. Right. But now, what will happen if I have another polygon? For example, a square, a pentagon, a hexagon. Could it be that the sum still adds up to 360 degrees? Let's see. Let's find out. In this case, I have a quadrilateral. Specifically, it's a square, right? Let's put this little mark here because we know these are right angles, right? Let's say this measures 90 degrees. This angle also measures 90 degrees. This one is also 90. And this one is also 90 degrees. Again, let's mark the four exterior angles. For example, I can mark them this way. We extend this line, we extend this line. We also extend this other one. And finally, we extend this other one. Now let's mark the four exterior angles. Here is one. Over here we have another. Over here is another one. And over here we have the other one, right? How much is this angle? Well, it's 90 degrees. How much is this one here? Also 90 degrees. This one is also 90 degrees. And this one is also 90 degrees. So I would have 90 plus 90 plus 90 plus 90. So let's see. Let's add them up. I can actually do this with multiplication, right? Let's multiply 90. 90 times 4. Well, that's easy because 4 times 9 is 36, and then I just add a 0. So that means that the sum of the exterior angles in this square is also 360 degrees. Is that just a coincidence? Let's try with the pentagon. Before I show you my drawing, I need us to look at this GeoGebra animation first. Here I'm going to show you a regular pentagon, and we're going to see what each of the interior angles in this pentagon measures. As you can see, each of the interior angles has to measure 108 degrees. We're about to see why. We've already done this in previous videos. I mean, I've already shown you where the formula comes from to calculate each of the interior angles in a regular pentagon. If you haven't seen that video, I'll leave it for you down here, and also up here, so you can watch it too. So look, each of these interior angles in a regular pentagon has to measure 108 degrees. Actually, the formula that's used is the following. Look, the sum of all the internal angles is calculated by doing 180 times n minus 2. So here I would have 180 times n, which is the number of sides or vertices, which in this case is 5 minus 2. So here I have 180 times 5 minus 2, which is 3. And well, 180 times. 3 is 540. This is what the sum of the interior angles in any pentagon should be. But since in this case it's a regular pentagon, this means that each of its interior angles measures the same. Therefore, I would have to divide 540. 540 by the number of sides, right? Which in this case is 5. Well, by the number of angles, which in this case is 5. Here I have 1 0. Bring down the 4 0. Here I bring down the 4, bring down the 0 and 8 fits. 8 times 5 is 4 0. 4 0. Minus 4 0 is 0. As you can see, when dividing 540 by 5 angles, it tells me that each of those angles must measure 108 degrees. So, let's write down that information here, because we're going to need it to calculate the sum of the exterior angles. Obviously, my drawing didn't turn out well at all, okay? But please ignore that part. Again, we're going to do exactly the same thing. Allow me then to extend each of these lines. We mark the exterior angles, which would be this one, this one, this one, this other one, and this other one I have over here. Let's see. Once again, we're going to do exactly the same thing. From 108 to reach 180. How much is missing? Well, 72, right? So here we have 72 degrees, because 72 plus 108 gives me 180. Here it's the same. This exterior angle has to measure 72 degrees. Same here. Well, let's continue. Same here. And over here it's the same. So, what should we get then? 72. 72 plus 72 plus 72 plus 72 and plus 72 should give me the same result as before, right? It should add up, but let's see if that's true. Because in the triangle, I got 360 degrees, the sum of the exterior angles. In the square, I also got 360 degrees. What happens in this one, let's find out. Let's do the multiplication. 72 times 5. 5 times 2 is 10 carry the 1. 5 times 7 is 35. 35 plus 1, 36. As you can see, I'm also getting 360 degrees. Look, with the triangle I got 360 degrees. With the square, also 360 degrees. And with the pentagon, I got exactly the same. And actually, this is not a coincidence. It turns out that whenever we add up the exterior angles of any polygon, the sum will be 360 degrees. With this then, we're saying that it does indeed hold true. And we're also seeing where it comes from. I want you to see something really interesting here. Look, with a little bit of imagination here. Please, if you were to move this angle, for example, over here. If you were to attach this angle over here. If you were to attach this angle over here. And if you were to attach this angle as well, it would actually make a full turn. That's why it has to add up to a total of 360 degrees. And this will hold true, I insist, regardless of the polygon we have. Let me write it here in big letters and in red so we don't forget. The sum is always 360 degrees done. Keep in mind, I'm referring to the sum of the exterior angles, right? Look, let's solve this exercise where they're asking us to determine the measure of angle x. As you can see, they're not giving us the measures of the interior angles, but we really don't need them, because all we need to know is that the sum of the measures of the exterior angles has to be 360 degrees. So what I'm going to do is add these three that they've already given me and see how much is left to reach 360, and that's going to be x, right? So let's go ahead and add the ones we already have. Let's do the addition. 5 plus 8 is 13, and plus 3 is 16. Carry the 1. Then here we have 1 plus 1 is 2 plus 1 is 3, and 3 plus 8 is 11. Carry the 1. 1 plus 1 is 2, and plus 1 is 3. I'm getting 316. Now we're just going to subtract. Let's see. I'll put it over here. We're going to subtract 316, which is the result of the sum, from 360 degrees. 10 minus 6 is 4. It becomes 5 minus 1 is 4. And here I have 3 minus 3, which is 0 done. So now we have that this exterior angle measures 44 degrees. All right, we're done. Let's move on to exercise number 2. In this case, they're giving me a hexagon. Look, it has 1, 2, 3, 4, 5, and 6 vertices. Now notice that they're giving me a total of 1, 2, 3, 4, and 5 measurements. They're only giving me the measurements of 5 exterior angles. So where do I get the other one from to start? Well, it's very simple. You see that here we have the other exterior angle. Since it's telling you that there are 90 degrees here, then there will also be 90 degrees over here. And now we're ready to solve this problem. Here they're asking us to calculate the value of x and also to calculate the measure of each of the exterior angles. So come on, let's do it. So I would have to write 3x plus x. Let me write it over here. Plus 3x plus 1.5x plus another 1.5x and plus 90. All right. And this has to add up to a total of 360 degrees, right? I'm just going to write 360. Let's add what has x and what doesn't. Allow me, I'll move it to the right side. Let's see. I'll do this addition first. 1.5x plus 1.5x is a total of 3x. Plus 3x is 6x, and plus 3x is 9x. So up to here, I already have 9x. Plus x, I end up with a total of 10x. So on the left side, we're going to have 10x. And on the right side, we have 360. And this 90, we're going to move it over as negative 90. We do the operations. 10x equals 360 minus 90, which leaves you with 270. We're going to divide by this 10, so it would be 270 divided by 10. And well, that's equal to 27 done. We already have the value of x that makes this equation true. With this, we can already know the measure of each of these angles, the exterior angles, right? So let's add them up. All right, let's substitute. Sorry. Let's start with the angles here that have a 3x, which would be this one and this other one. So that would be 27 times 3. 27 times 3 is equal to 81. That means then that this exterior angle measures 81 degrees. And also this angle over here measures 81 degrees. Now let's go with the ones that are just x, nothing else. This angle, this one I have right here, right? This would simply be 27, so let's write it down. And over here we have 1.5x, 1.5 times 27. Let me do the calculation here. I get a total of 40.5. So this angle measures 40.5 degrees. And the same goes for this one, right? It also measures 40.5 degrees done. We've finished the exercise. But before moving on to the next one, let's check if what we've done is correct. For this, it will be enough to add up all the exterior angles. And the sum, in fact, should give me 360 degrees, right? So let's see. I'm going to put 81 plus 27 plus 81 plus 40.5, which I'll put twice, and plus 90. All right, we have all 6 angles in total, right? Let's see. 1, 2, 3, 4, 5, and 6 done. The sum has to be 360 degrees. Let's see if that's true. 5 plus 5 is 10. We carry the 1. Bring down the decimal point. Here I have 2, 3, that would be 10. 10 in total. Here I have 9 plus 2, that's 11. Then it's 1923, 2736. I'm getting a total of 360. So as you can see, what we've done is correct. Now let's move on to the last exercise. As you can see, in this case, they're giving me the measurements in terms of x, but for the interior angles. And we have to calculate the measures of the exterior angles. So the first thing I'm going to do is determine the value of x. Once I have the value of x, I'll have to determine the measure of the interior angles, and then we'll calculate the measure of the exterior angles. So come on, let's do it step by step. First then, I would have to add this angle with this one, with this one, with this one, and with this one. And in total, that should give me 540 degrees. Right? Or well, we're going to set it equal to 540 degrees? Why is that? Because we agreed that in pentagons, the sum of the interior angles has to be 540 degrees. Right? We saw that at the beginning. So let's go ahead and add it up. Look, I'm going to add right away. Pay attention here. The x's with the x's, and what doesn't have x with what doesn't have x. So let's start with the x's. We have 1 plus 2, is 3 plus 1, is 4 plus 1, is 5, and plus 1 is 6. So in total we have 6x. Now let's add what doesn't have x. Let's see, this part is a little more complicated, right? I'll start with the positive numbers. All right, here we have 20. Here we have 11 plus 14, that makes 25 plus 20 is 45. And 45 plus 15 gives me 60, and 60 minus 60 leaves me with 0, right? So the sum of these numbers alone is just giving me 0. Therefore, here I would have 6x plus 0, I insist. I have to set this equal to 540. So come on, let's solve for the value of x here. That leaves me with 540 divided by 6. Let's do the division. 9 times 6 is 54. Subtract 54, that's 0. Bring down the 0, it fits 0 times, and the remainder is 0 done. So I end up with a total of 90. This is the value of x that makes the equation true. That is, the sum of the interior angles has to be 540 degrees since it's a pentagon. Now let's calculate the measure, now for real, of each of these angles. Well, it's simple, right? Because, for example, this one has to measure 90 plus 11. And 90 plus 11 is 101, right? So this angle has to measure a total of 101 degrees easy. Let's go with this other one. Here we have 90 plus 20, that gives us a total of 110. So this angle measures 110 degrees. Let's see this other one. Here we have 90 plus 15. That would be 105. This angle measures 105 degrees. Let's continue here. 90 plus 14, which would be 104. We write it down, and finally, this one is 2 times x minus 60. Let's see. 2 times 90 is 180, right? And 180 minus 60 leaves me with 120. Done. Now we have the measure of each of the interior angles. Now, by subtraction, we're going to have to calculate the measure of each of the exterior angles. But that's easy now, right? Just like we did a little while ago. Here we already have 120. To get to 180, I'm missing 60 degrees. Here we have 104 to get to 180. I'm missing 76 degrees. Here we have 105. To get to 180, I'm missing 75 degrees. Here we have 101. To get to 180, I'm missing 79 degrees. Here we have 110. To get to 180, I'm missing 70 degrees. Finally, it doesn't hurt to check that when we add up all the exterior angles, we should get 360 degrees. Let's see if that's true. Let me erase this part to make a little more space. All right, let's get started then. 70 plus 60, then plus 76. Then plus 75, and finally plus 79. I have all 5 now. All right, here I have 9 plus 5 is 14, plus 6 is 20. We're doing well. Here it's 9. 9 plus 6 is 15 plus 7 is 22. 22 plus 7 is 29, and 29 plus 7 is 36. How can you tell if I'm getting 360 degrees? With that, we're confirming that what we've done is correct. And look, before finishing the video, I have a small question for you to think about. Just something to reflect on. Imagine you have a regular polygon, whichever one you want, with as many sides as you like. For example, it could have 15 sides, 20 sides, whatever you want. Now the question is, how would you calculate the measure of each of the exterior angles of that polygon? Think of any polygon, and then say how you would calculate the measure of each of those exterior angles, considering that the polygon is regular. Please think about it, and when you have the answer, put it down here in the comments. That way, I'll see if you really understood what I just told you. And also, for homework, please tell me how much each of the exterior angles measures in a regular decagon. Please do it, and when you have the answer, put it down here. Well, that's all for today. I hope this video was helpful, and, above all, that you enjoyed it. If you liked it, please subscribe to this channel. I upload videos every day. See you next time. Take care and behave well. Bye.